room.
Okay. All right. I'm sure people are going to keep coming in here, but I'd like to get started. So, welcome everybody. I see a lot of familiar faces tonight. I see some faces that I'm not recognizing. So, welcome back and welcome. I'm Dave Farina, club president, and we've got a really cool discussion tonight, and it's going to be a little bit different than usual. So if you checked out the website, you may know our main discussion topic tonight is going to be the New Horizons mission and Pluto update. We had a few months back, Dr. Erin Crail from Kutztown came in and she discussed New Horizons. Before we actually made it to Pluto, it didn't have a whole lot of information. I'm going to do an update tonight, but it is by no means going to be the complete story. We only have preliminary data at this point, and it's going to be months, 16 months in total until we get all the information. So, can someone let Rob in? Thank you. I don't know why it wasn't locked for me. Anyway, so yes, that's what we're going to be talking about. We also have some discussion from Lane regarding the upcoming lunar eclipse, as well as some discussion on his experience at the Black Dwarf Star Party. At that point, we'll get into some stuff with the New Horizons mission. And to start us off, let's take a look at our calendar in the coming month. So we have 4 different events on the calendar that are coming up in the next 2 weeks or so, 3 weeks. The next one, next Wednesday, the 23rd, is going to be our AELC member training part 2. We had a handful of folks show up for the first one. These are member exclusive events to help you in any way that you would like, or share your knowledge. If you're coming in with some knowledge about telescopes, about observing, about astronomy in general. So if you are not a member and would like to join, let me know, or Lane, club vice president, and we'll point you to how to sign up. For members, just as a reminder, bring your telescopes with you. If we have a clear night, the game plan is and was last time to go out and do some observing. Last time we had a decent turnout and worked out pretty well. We had nice clear skies. I think one of the best nights we've had, if I remember correctly. And we were able to do some serious training. So, if, however, it is a not so nice night, we are still on. We have the inside of the Environmental Center booked, so if there's rain, we would still keep going. We would just do stuff indoors at that point. Lunar eclipse, as I said, is coming up. Lane will talk about that in a few minutes, as well as occultation of Aldebaran coming up, and we'll talk about that. And that's our public Star Watch. So we are quite busy here in the next 3 weeks or so. And then we'll make a call, if you're not familiar with how this works, we'll make a call by probably Wednesday or Thursday for which day, either Friday or Saturday, it's going to be based upon the weather conditions that we know at the time, which is, of course, a forecast. So, we'll have to make a call, and it is what it is. But keep in mind, that is subject to change if things turn on us. These can be canceled. Okay, and Lane will be the one to post that. All right. So also, he's in the house tonight. Our very own Rob Webb. Rob, can you stand up for everybody to see you?
Hello.
So, yes. Thank you, Rob. Rob is extremely busy with school.
School's going.
And still has time for us to make these Observing with Webbs each month. So we've got a September Observing with Webb up. And I assume that there's something about the eclipse in there as well.
Indeed.
You mind if Lane goes first and steals some of your upcoming thunder?
Absolutely.
All right, so I'll have Lane come up and talk about.
No, why don't we do Rob first? That way, if he covers it, I don't have to.
I thought it might be interesting for us to have the information first before we view the Rob's video, because then you can understand it maybe a little bit better. All right?
Oh, no problem.
That would be my thing, and then we have this information coming in. Am I putting you on the spot here, Lee?
You did not.
Darn.
Good try. Okay. Couple of things about this. First of all, you don't have to go anywhere. In other words, as long as you can find the moon, it can be out of your backyard or in your front yard or the park down the street or whatever, to watch this. It really gets going about 9 p.m. This is the 27th. They say the 28th. It starts on the 27th. All right? By 9 p.m. it's noticeable. You can see it happening. And what's going to happen is the Earth is going to pass through, the moon's going to pass through the shadow of the Earth projected up in the sky. I just want to point out a couple of things. First of all, the shadow of the Earth is always projected up into space opposite the side of the sun. So it's always there day and night. It's just that we have no, as amateurs, we have no way of actually seeing where it is unless something passes through it. So it's a chance to understand what's going on here. So that's the red part is the shadow of the Earth. It's very faint here, but there's also a fainter part of the shadow, 2 layers out around here. But in the sun, the moon actually comes into that fainter part around 8 o'clock, but you won't notice it unless you have some kind of equipment to measure very small changes in brightness. Your eyes generally won't do it. So when it actually gets into the dark part of the Earth's shadow, that's when you really begin to notice it. Now, one thing that is a lot of people have trouble with in the beginning is just imagine we're looking up at the moon right now, and earlier, say an hour earlier, we look at the moon and it's here and just looks normal. And so, which direction, which side of the moon do you think will hit the shadow first? The left. Because that's the true motion of the moon through its orbit. We're used to, if we're looking south, the moon rises over there, the full moon, at about sunset, sweeps slowly across the sky, and if you're up at sunrise, it's going to be in the west. But that's the Earth's motion that's carrying the moon in that direction. The actual motion of the moon through its orbit is to the left, towards the east. So that's the point of first contact, and that'll, by 9 o'clock, that'll be just happening. Okay, by 10 o'clock, the moon's going to be more or less here. Now notice, this one is not, it's not going to go through the center. This is the darkest part right here, this area, the darkest part of the Earth's shadow. So what's going to happen is, the moon, you'll see a gradient in the moon, and that the upper part right here is going to be darker than the lower part. This graphic depicts this whole red area as the same darkness. It's not. It's a gradient that gets darker towards the sun. So look for those 2 things. First of all, it's the left side of the moon that gets lit first, which is a little counterintuitive. And the other thing is the top of the moon should be a little darker than the bottom of the moon. So, and this is just about a perfect eclipse. It occurs in the evening. It's not late. But so, of course, it's going to get clouded out.
Lane, could you just speak briefly on why it was red?
Well, yes, but I like your description best of all, but I'll try to replicate it. Okay.
I can do it if you want.
You would think this part of the shadow would be what color? Black, right, or some dark gray or something like that. But that's not the color of that circle. And here's the reason why. Imagine you're on the moon looking back at the Earth, okay, and you're seeing that that would be a total solar eclipse at that point. If you were standing on the moon, the Earth would be blocking out the sun entirely. Now here's the thing. The Earth has an atmosphere, unlike the moon. And what you would see on the Earth would be, the Earth, of course, you're looking at the dark side, so it's completely black if you're standing on the moon looking at it. But there would be a ring of red around it. And that's because of the refraction of sunlight through the Earth's atmosphere. A way I've heard it expressed that's really nice is, if you take all the sunsets on Earth and add them together, that's the color of that. So it's like when we look at the sun when it's right on the horizon. Okay, it's pretty red, right? Okay, that's what you're seeing. That's the dark part of the shadow that's getting projected into space. So it's dark, but it's not black. It's actually a very deep red. So that'll be the color of it. Anything else you can think of? All right, with that? All right.
Not necessary.
Okay, how do I get to
What would you like to get?
our calendar?
The first page, if you like to get out of it.
I don't know how you want to do that. Okay. Always keep an eye on our calendar, by the way. It's tuned to things that are going here in Lancaster County, Pennsylvania. So we cover the lunar eclipse. A note here, 9 p.m. You can go anywhere to see it, including nowhere, just out in your backyard. The next thing that's going on is going to be something really tricky, and this is for you folks that have telescopes and have a little bit of experience with them. This event involves the moon, but it's unrelated to that eclipse. This is completely different. The moon is going to occult, that is cover up. That's all the word occult means, is to hide. The star Aldebaran today. That's Friday, October 2nd, from 10 a.m. to 11 a.m. The disappearance will occur about 10:03 a.m. Well, that's broad daylight. But believe it or not, if you have a telescope, you can see things up in the sky in the daytime. And this kind of event is one of the easiest ways to get into doing daytime astronomy, because you can usually see the moon in the daytime. Okay? If it's a clear enough day, you'll have no trouble finding the moon. How many people have seen the moon in the daytime? Lots of us. All right. So find the moon and start getting ready around 9:30. Set up your telescope, put it in the moon. Begin with a magnification that shows the whole disk of the moon, so fairly low power. You should be able to see the star in there. Okay, if not, boost the magnification a bit and scan around the edge of the moon, and you should be able to find the star Aldebaran. It's pretty bright. The star will be on the illuminated side of the moon. So the moon at that point is not fully illuminated. It's not a full moon. And by the way, lunar eclipses are always on the full moon. So it's going to be, like I say, find the illuminated side of the moon. I don't say left or right side, because depending on your telescope, it might flip the moon upside down or left or right. Just find the side that's lit with the right piece. Find the star, and occultation will begin when the star touches the edge of the moon and blinks out. It'll blink out like that. And that's how astronomers 300 years ago knew there was no atmosphere on the moon. Because if there was an atmosphere, the star would fade out as it got closer to the edge of the moon. Instead, like I said, it just blinks out in a split second. It'll reappear in a blink from behind the dark side of the moon. That, by my experience, that can be a tougher thing to do. Give it a try. And I also note that the times should be correct for this location, for Lancaster County, but better allow plus or minus 3 minutes or so. Any questions about that? Is anybody going to try it? You should. Okay. Now, I don't know if it would work in binoculars, but yeah, we'll do. Are you going to try too?
When is it? In the morning?
Yeah.
On a Friday?
On a Friday.
At 10 a.m.
Yeah.
Take your kids out.
Yeah.
Yeah.
I might just do that. That's actually during my prep, so I might be able to do that.
Yes.
I'm gonna try it, but I'm gonna be in Cape May, New Jersey. You think what about the time?
The times will be no more than 5 minutes different.
Okay.
Trying to remember whether it should be before or after. No, I take that back. Well, yeah, they'll be a little different. The astronomical events are a little different because they work on local time, not time zones. The universe doesn't know about our human zones, how we divided things up. So it's always on local time. So there will be a small difference between here and Cape May. All right. A couple of other things. Come on. Let me pull my notes out of my backpack. One of the things you saw on the calendar was the Black Forest Star Party. A couple of quick notes on that. It's held every year. In fact, there's 2 major star parties, really astronomy festivals up at Cherry Springs State Park in Potter County. One of the darkest places on the East Coast, and the state's trying to keep it that way. I can show you a typical, I hope that's you.
I'm trying to remember.
Should have something on here that says astronomy field. I guess I missed something. It's a big open field. It's an astronomy park. It's a state park. You're only allowed to go there to do astronomy. Only red lights event allows. No campfires, that kind of thing. But you can camp there, park your car there right next to your telescope or your blanket or whatever you're using with astronomy. Once it gets dark, you can't drive on or off. Okay, you're stuck there for the whole night, unless there's an emergency. There's usually anywhere between 50 and 100 people there. The field can officially hold 500. Okay, and I've seen it full on occasion. It's a big open grass field, beautiful place. Boy, I don't know where my picture went. Anyway, you'll get, here's a picture I took of a friend of mine. You can see all the campers in the background, trailers and all that kind of stuff. That's Guy Camp with Ken, he's out of Philadelphia. He has one of the biggest telescopes there.
Do they have electric hookups?
Yes.
Oh.
There are electric posts all over the field that you're allowed to use for astronomy, but you can't run your trailer air conditioner off of it.
Is the Wi-Fi only during the black?
Wi-Fi is there.
All year long?
All year long. All year long. Even when you don't want to be there, because there's 20 inches of snow. This year we had 2 aurora. This occurred in the morning, 4 a.m., Friday morning. Unexpected. I just got beeped on my, I have an app on my phone, of course. There's an app for everything. it beeps me when there's the possibility of an aurora where I am. And it beeped, and about the time somebody else yelled out, there's an aurora coming. Unfortunately, this one came up real fast, in about 3 minutes, flared, and then started dying back down. I was running around in the dark, trying to get my tripod set up, put my camera on it, knocked it over, picked it back up, trying to focus it manually, which is a lesson. But anyway, this will give you some concept of the colors you get. Can we get the lights down just a little bit? So these are trees along the northern horizon. That's not what a star looks like. So here's the big dipper by the way. And the green is usually the first color you're going to see in an aurora. And then you'll get a red layer. Sometimes this can be very bright, with a very brilliant red. And then if there's more energy involved, you'll get this purplish haze up here, which can form spikes coming up like that. And this one had all those. It was not a super high energy event, so the aurora itself stayed low on the horizon like that. And let's see. After I got the camera focused, of course, it was already dying down. That's just an alien. Ignore that. And here's the big dipper still over here. There's the bowl. There's the handle coming there. Those eyes are an Alcor, the double star. You can see with just your eyes. But, so look next time. Same trees that mark the north. And so you still have a little bit of green and a little bit of purple up here. Most of the red is down there. How many people have seen an aurora? They occur pretty regularly. The app on my phone this year has rung out at least a half a dozen times saying there's no aurora over the place. And it was always in the daytime. So, luck of the draw. Any questions about aurora? Yes?
Did you know that aurora borealis can cause trouble with satellites?
If it's strong enough, yes. You can disrupt radio communication to the minimum. You can do a lot of things. And let's see, I showed you that one. This is Orion, by the way, just a quick 15-second shot. Anybody can do this. You just put your camera on a tripod, shoot for 15 seconds. This is the kind of star field you can get. That's the Orion Nebula right there. That's not a star. We talked about that before. It's a place where it's a giant gas cloud where stars are invading. Okay, we're going to come back. No, we're not going to come back. All right. There were also talks, some very good ones, on Saturday, and of course we got to see a lot of friends. Shirley, do you have anything to add to that? You were there.
No, the talks are really good. Other than it rained all day Saturday, it was miserable, but it worked out all okay. I didn't get to see the aurora, which I wish, but I saw your pictures, so I guess I'm just gonna.
Yeah, I felt bad about the aurora because about 5 minutes after somebody yelled aurora, a whole bunch of people stumbled under their tents and it was all gone.
It's gone, sorry.
All right, let's see. I wanted to talk about just a few things. How are we doing on time? I'll keep, hurry up. A couple of things I shot recently. This is a combination object. First of all, there's a nebula here, big one. Okay, it covers the whole screen. All the stars you see are in front of that nebula. So there's this giant black cloud there up in space, and we've got hundreds of these scattered through the nebula. And this is a hole in the side of that cloud that has formed inside it is a cluster, an open cluster of stars that were formed out of this gas cloud. They've blown a hole in the side like that. So these stars are actually part of that open cluster. And that, I believe it's that one, is a hot enough star to actually ionize the hydrogen gas, which is the bulk of the clouds, ozone, and ionize hydrogen. So those of you who like to get into imaging the night sky, that was taken out of my backyard here in Lancaster County. Any questions on that? Where stars are being formed. This particular one, the common name is called the Pluto Nebula, but it has 4 or 5 catalog definitions. It's about 4,000 light years away, so we're seeing it like it was 4,000 years ago. It formed about 100,000 years ago. It's about 15 light years across. And that's about all the information I could find out about it. And the one other thing that we'll look at, here's how many people have seen the Pleiades star cluster. Okay, it's starting to come up now earlier in the night. So by end of October, it'll be well up in the evening. Just look in the east. It's this tiny, it looks like a tiny little dipper. A lot of people mistake it for the little dipper, but it's not. It's an open cluster of stars. Every bright star you see here are part of the Pleiades star cluster. And this star cluster has a motion, it's moving from our perspective towards the foot of Orion right now. And it has moved out of the gas cloud it was born in, which happens to all open clusters. But it's also, at this point, passing through a particularly thick section of interstellar dust. And so that's what you're seeing here. All these stars are bluish, they're very bright, and their light is reflecting off of all this interstellar dust. It makes some interesting patterns. This is called the Pleiades, or the Seven Sisters. It's probably one of the most iconic group of stars from a cultural standpoint. I would encourage you to go look at Wikipedia, look up the Pleiades, or the catalog designation, N45, and you'll see almost every major culture in the world has their own mythology and stories and such surrounding this cluster of stars. So here in the West, we call it typically the Pleiades, or the Seven Sisters. For example, in Japan, they call it Subaru. And if you look at the logo of Subaru, it's a stylized version of these stars. There's about 1,000 stars in there altogether. And they were formed about 100 million years ago. They're pretty close to us, only several hundred light years away. And they're not gravitationally bound, even though they're moving together. They're too far apart. They'll probably last about another 250 million years before they're totally dispersed across the sky, and you can't even tell they're launched together. Any questions about that? Okay, I'm done.
I have a question.
Yes.
It was around 20 or so years ago, I heard on the radio that there was this lunar eclipse at dawn, or around dawn. And they said it was very rare, it wouldn't happen again for like 800 years. And that made me wondering why. Is that it's coincidence that it's always night for us when there's a lunar eclipse? And I guess my question is...
No, that's just for us. Lunar eclipses can happen anytime, okay? But I mean in the sense that we can be on the day side ourselves, and there's a lunar eclipse going on the other side of the
Okay, that was my other question. It was just very rare, just a coincidence that...
I'd be surprised about the 800-year thing.
Well,
Because I watched one at dawn 3 years ago, I think.
Oh, well, there goes that out the window.
What?
There goes that out the window, but it was a good excuse for my boss telling him why I was late. Don't worry, it won't happen again. Right?
Mum's the word.
Yep, mum's the word.
All right, folks. So as I was alluding to earlier, Rob has been doing these really neat monthly astronomy things with a program called Starry Night, and we're going to play one for you tonight. So if you're ever interested, it's on the website. as well as the past ones as well, under the Observing with Web tab.
If you have any questions as we go, we'll pause at the end and feel free to ask any questions.
Okay. And so I think with like Lane's discussion here, and you might see some of these objects, so keep them in mind as we're watching the
Hi
video.
everybody, and welcome to Observing with Web for September of 2015, the video. So we've got some cool things going on this month. Most importantly, we have a total lunar eclipse, and it's got great timing because it starts after 8-9 p.m. and it ends by 12:30 in the morning. So it's great timing for us, at least on the East Coast. And we've got a couple planets that we can see as well. So let's just get right into it because they got a lot to cover. As far as the planets go, here's what we got going on. If you take a look at the night sky, I have it set for September 15th, a little after sunset. You notice the ecliptic, that path that the sun and moon travel, is pretty low in the sky. But if you look toward the southwest, you'll see Saturn up here. Saturn is over here in the southwest, and it's off to the right of, just lost the name, Antares. Wow, that was bad. First week of school, Friday. It'll do that. But anyway, it's going to move across the west, and it's going to set around about 10 p.m., somewhere around there. So you won't be able to see it. Let me rewind the clock a little bit. And in fact, if you zoom in on Saturn, it's a great time to look at Saturn because of the way that the rings are aligned, or not aligned, if you will. So go out there and get your telescope and take a look at Saturn. Also, on the 18th is a good time to look if you're having trouble finding it, because on the 18th, the moon is right nearby Saturn. If you can find the nice crescent moon, Saturn is off to the left and a little bit lower than the moon. All right, so Saturn's really the only planet you can see for a long, long time. You won't see any other planets on the ecliptic, at least not naked eye ones, until, well, let's keep going forward, until about 4 a.m. Oh, there's Venus popping through. And so Venus is going to pop through a little bit after 4 a.m. and it's going to get higher in the sky as the month goes along. So just keep looking in the morning. Now what's going to happen is throughout the morning, evening, that's going to rise up, and then about a half an hour later, Mars, which is dimmer and more red, is also going to pop up as well. And then a little bit later after that, right as it's reaching dawn, you'll see Jupiter rising up as well. And so let me just put this at sunrise. You see at sunrise, Jupiter's high, but let's go back a little bit. Let me run you through this throughout the month. If you start on the 1st, really, Venus and Mars are kind of next to each other. But then Venus is going to go up. Mars is actually going to get close to Leo's brightest star, Regulus. And by the end of the month, you've got a nice 3 planets in the dark sky in the morning. You've got Venus, Mars, and Jupiter. Mercury is the one I didn't talk about. It's a naked eye planet, but it's in the sun's glare all month, so just ignore it. So to summarize, we've got Jupiter, Mars, and Venus in the morning sky off in the east, and Saturn off in the west around sunset. Okay? All right, let's talk about the events for the month. So let me go back to September 4th. September 4th is interesting because what you'll be able to do is watch the moon uncover Aldebaran. Okay, and let me select that one and center on that. And what you'll notice is that on the 5th, the moon actually passes through or past Aldebaran. And in fact, I'm seeing that around 12:38 a.m., at least for people around us, Antares will pop back out on that.
This is a different occultation.
I don't normally get
Lane's talking
giddy about these occultations.
This was
but this was neat because it's a very bright star. Where we can see it around 12:38 in the morning. It's kind of weird, but it's neat. And, on the Podbean site, you can see a link to where you can get specific times. All right, so let's move back out. September 5th is when you have that last quarter moon, as you can see here. Left-hand side is lit up. You can see it in the morning, and if we fast forward time, after midnight and into the morning. What's going to happen is that moon is going to get skinnier and skinnier and skinnier, and lower in the morning sky until September 10th. September 10th, this is pretty cool. You've got the moon hanging out, a very thin crescent moon, hanging out right in between Venus and Mars. So if you want to see some of those morning planets and the moon, check it out on September 10th. As you can see, Venus is going to be to the right, Mars is to the left, and the moon not in the middle, a little bit closer to Venus. Let's see, let's zoom out. And over the next couple of days, 10th, 11th, 12th, and finally on the 13th, you've got the new moon, and now the moon is going to start rising up in the west after sunset. Let's see, in fact, 13th, 14th, let me zoom in a little bit here. 15th, you can actually see the moon maybe. 16th, thicker and higher. 17th, thicker and higher. And 18th is a good time to check out the crescent moon because you'll see Saturn only about 3 degrees below and to the left of the moon. And by 10 p.m., they'll be setting in the west, so we can't see them. So, again, if you're looking for Saturn, look on the 18th. Zoom back out a little bit. If you keep track of the moon over the next couple days, 1, 2, 3, on the 21st, you get the first quarter moon. The right half is lit up. You can only see this from sunset, maybe in the evening, like 4, 5, 6 o'clock. But from sunset until about midnight. Let's see, that's September 23rd. That's when you have, well, nothing interesting about the moon, but it is the fall equinox. That's when all of the locations on Earth experience about 12 hours a day and 12 hours a night, almost exactly, just because of the way it's situated and the tilt of the Earth's axis, but I'll let you find more about that on the internet. And then lastly, almost lastly, second to last, on the 24th, you will see a close encounter between Mars and Regulus. But you have to wait until the morning. So let me fast forward time as I look east. And oh, there's Mars and Regulus getting very close together. And finally, the best part of the month, we're going to go to sunset, September 27th, and we're going to fast forward. Oh, there's the moon rising up about 7:20, and just an hour after that is when the total lunar eclipse starts. Now, let me talk about some times here and what you're going to see. Okay, let me center on the moon. Okay, all right, now. Look to the east, around 7:20, you'll see the moon. What's going to happen is the moon's going to rise up, okay? And right at about, I have it as 8:40. Right at about 8:40 is when the penumbral lunar eclipse will start. This means almost nothing, okay? You can barely see the penumbra. That's the outer portion of the Earth's shadow. On here, it's going to look like it does something, but when you're out there, you really don't see it. So don't get discouraged if you don't see anything at 8:40. Okay? The real action starts at about 9:07. Okay? At about 9:07, that's when the umbra, the dark inner portion of the Earth's shadow, the moon starts entering that portion. And so what you'll see is that from 9:07 and on, the moon starts getting eaten up and eaten up and eaten up by the Earth's shadow. And then totality starts at about 10:11 p.m. Now, here's the thing. If you just go out after 10 o'clock and you're looking for the moon, well, it's hard to see because it's not getting as much light. So if you're looking then, look toward the southeast, see if you can find it there. And then what's going to happen is totality is actually going to last an hour and 12 minutes. What's going to happen is barely you can see it on here. It's just going to get a little bit darker. It should get the darkest at about 10:48. Now, why is it dark? It's in the shadow. But why do you still see it as reddish orange? The reason is that if you were on the moon, think about this, you would see the Earth passing in front of the sun, blocking all of the sun's light, except the Earth has an atmosphere. And that atmosphere allows light to pass through it, but not all light. Just the red and orange, maybe a little bit yellow. The mostly red and orange part of the light gets passed through. Most of the rest of it gets scattered within the atmosphere that's there. But the red and orange, a little bit yellow, passes through and actually bends. Some of it bends toward the surface of the sun. And so what you would see if you were an astronaut, you would see the Earth with a nice red ring around it, which would be super cool. And essentially what you're seeing, being projected on the moon, is all of the sunsets and sunrises all at once from the Earth. And it's the darkest at about 10:48. Then time's going to pass by, and at about 11:23, that's when the totality ends, and the moon comes out of the Earth's shadow. And that ends at about 12:27. And that's when it's in the penumbra again, but you don't really see it. It shows it on here. And then, let's see, 7, yeah. But anyway, that is about it. I believe the final 12:55 a.m. is when the penumbra leaves. Okay. But anyway, that is the total lunar eclipse. I would encourage all of you to go out and see it. It's really neat to be able to see a moon and all the constellations, because typically the moon rounds out a lot of that light, and you can't see many of the constellations. Also, I feel like the moon gets more of a 3D effect when it's in eclipse. Anyway, I hope you guys get to go out and see that. If we're talking about constellations, I think I'll take like 1 minute to talk about the constellations. It's summer, so if you go out, well actually no, it's not really summer, it's the end of summer, going into fall. If you go out, let's say after sunset, around 8:30, something like that, you'll see the summer triangle of Cygnus, Lyra, and Aquila. And then if you wait a little longer, wait till midnight, you start seeing the fall constellations. Pegasus with the great square, and Andromeda with the beautiful Andromeda galaxy. There we go. And if you wait even longer into the morning, you'll start seeing the winter constellations popping up. Taurus, Auriga, Orion. But you'll get more chances to see them, right? Let's see, and you know what, I think that's pretty good. I really hope that you get to go see the total lunar eclipse. I know it's really, really cool. We won't have another one for, I believe, 2 years, something like that. And, yeah. Again, this was Observing the Web, and I wish you very clear, dark skies for the month of September. Hi everybody, and welcome to Observing the Web.
All right, thanks,
August 2015.
Does anybody have any questions
August
for
turns
Rob?
out to be, well, not so exciting in some ways, but very exciting in another.
I actually have a question for anybody who's been out early in the morning. I've been able to see Venus out there, nice and bright, easy to see, even just about at sunrise you can make it out, and some of my students have seen it. Has anybody seen Mars or Jupiter in the morning yet? I feel like I've been looking and I just haven't been able to see them. They're just not bright enough.
Last time I was up all night, I didn't even try to see those two. I saw Venus. You can't miss it.
Yeah.
It's so bright it casts a shadow.
Yeah. But do you guys have any questions about eclipse or anything? Yeah.
The moon is passing in front of Aldebaran,
Yes.
so it looks like it's going to disappear. Not just wink out. I don't know.
Oh, you know what?
About winking out.
No, it is going to wink out. Not that I know, I'm pretty sure that it will wink out. It just doesn't look like it on the on there because it makes the brighter stars bigger dots.
Okay.
But any star that you look at is just going to be a dot in the sky. It's just that one is brighter than the other. But since there's no atmosphere on the moon, then it'll just wink out. So yeah, from what I can tell, the occultations, which I normally don't ever pay attention to, but this one coming up seems pretty cool. Like you just have to keep watching the moon and don't take your eye off because you'll miss it. So, yeah. Yeah.
Unrelated question.
Mm-hmm.
How did you make out with the Perseids at Cape May?
Oh, Perseids, yeah. Let's see, I was around Cape May. I personally saw probably about 5 really bright ones that went across the entire sky, and it was beautiful. It was great. I was actually in Wildwood, that's close enough to Cape May.
Well, I was in North Wildwood.
Okay.
We saw 30 in about an hour and a half.
Nice, nice. Yeah, we were unable to see some of the dimmer ones because I think Wildwood was really like pollution-y, if that's a word. And then I guess Cape May and Southern, or Philly, that's what it was that I were able to see. But I think I caught 3 faint ones on my camera. But that was about it. It was good. So you were in North Wildwood and you saw the nice. It was a good one.
Any other questions? Okay, so I wanted to point out, I have been trying to do this for a number of months and have been talking about it for a number of months, and finally we, the club officers, decided that we would like to really get these on video so that if you missed one and you really wanted to come and you just couldn't make it, that you had some way of viewing these discussions. And so we are videotaping this, and if you miss a future event, I'm going to try to do all of them and get them up on YouTube, on our AELC YouTube channel. I also have links here for other things, the Observing with Web category, as I was talking about just now, but I'm also adding things as we go under our playlists. So I added a few today. I just added these. I do my best to find either one of 2 things. Either I've fully watched them myself, or I know that they are reputable sources, because I know that folks are interested and don't necessarily always know what resources are out there. And I do. It's what I do for a living. I teach at Manheim Township High School as an astronomy teacher. These are things I do on my daily basis anyway, and so I might as well share that with you. So check these out. I'm not going to play them. In fact, some of these videos, as I said, I haven't watched them all. I just checked.
It sounds like science.
That's not what I'm going to do. This one, for instance, right here, I believe it's an hour long, HD Universe channel, and it is as up to date as it'll get. And I imagine that it will quickly be out of date. And I'll explain why that is soon. So they may have jumped the gun here a little bit, making an hour-long documentary on something we just learned about. But hey, that's great. I'm glad it's up. NASA channel, and just some other ones I was able to watch because they're shorter. We might watch one of those later on. So that's that. And I have other playlists as well. We're going to do something a little bit different tonight. Rather than go to a PowerPoint presentation, I was doing my research for this discussion on Saturday when it was all raining outside, and I was sitting out looking out the window thinking, oh man, there's nothing to do. I should probably use this time and do my Pluto brushing up. And so I have an app on my phone, and you're welcome to follow along if you would like. This is an app called Pluto Safari, and I'm not going to be offended if you have your phone out and are playing around with it, because I'm hoping that you check this out. So it's in iOS for Apple phones and Androids, and I have it pulled up here. So, hey, look, it looks just like what's on the screen. So this is what I used. I spent about 5 hours reading every article I could possibly read from day one, which hopefully you don't have to do now if you were willing to listen to me. So, one thing I thought was pretty neat that I'm just going to start us off with is this timeline. The timeline, just to give you a sense of the time period we're talking about, the launch for New Horizons, and for those of you who saw the New Horizons discussion by Dr. Crail, some of this is going to be a little bit of a review for you. We left on launch day in January of 2006. It just arrived this past summer. So we have a 9-year mission. It's the fastest human-made object to date, and that's how long it takes. It's a big solar system, and Pluto's out there really far, and yeah. So the time periods we're talking about here, you know, can you imagine being the scientist waiting 9 years for your mission, which, by the way, does not happen immediately. You have to build the thing first. You have to figure out what you want to do with it first, then build it, then hope it doesn't blow up on the launch pad. It launches, and then you have to wait 9 years. That's a career. That's a career. And they waited their entire career, and it paid off. And it's hopefully it continues to pay off for the months to come. I'm not going to go through every one of these, but just kind of flip through them quick. You can watch the dates here as we go. Anything that is of serious interest, we'll talk about. And tell me if they want to stop on one. That's an interesting one. So the instrumentation on this, it has a telescope. And so its telescope initially took a picture back in 2006. And this is, you're doing the paces of these instruments, you're making sure they're working okay. And so you want to know pretty quickly, did it survive launch? Is it capable of taking a clear image with the detail we are expecting? And it was. And so they were very happy.
Dave, do you know what, not specifics, but what kind of telescope it was?
I do not. I would imagine it's probably something like a Schmidt-Cassegrain, based on the fact that it's a very collapsed version of a telescope. For those of you not familiar necessarily with all the telescope types, there are many different designs, and a Schmidt-Cassegrain is it's able to be very big and have a very long focal length, which provides it a lot of zooming capability. Tell me if I'm wrong, Lane, at anything I say here, because Lane's a lot better with telescopes than I am. But when you take a Schmidt-Cassegrain, the light gets bounced around a few times inside of the scope, which provides you a nice long focal length, but a shorter telescope in its actual physical size. Okay, so it goes down, it hits a mirror, it goes up, it hits another mirror, and then it goes all the way back to the telescope. So it literally collapses it by 3 times the normal length. And so that's why I think it would be something like that. Maybe you guys can fact check it. So first Pluto image. Next one is actually really important. Okay, they do this navigation exercise near Jupiter. This is twofold. First, does its navigation things work? Does it have the ability to turn on the thrusters that allow it to navigate? Are its gyroscopes, which allow it to point at things, working properly? But more importantly than all of this, Jupiter serves as a way to make the spacecraft move faster. We do what's called a gravitational assist. We allow Jupiter's gravity to speed up the spacecraft. And this is an essential part of any deep solar system mission. We have to do this, or we're going to get there, and it's going to take much, much longer than 9 years. So there's our Jupiter flyby, passing Saturn. We can check some stuff out. They did do some science on some of Saturn's moons, but it was more to test the machinery. We've got plenty of things in orbit around Jupiter and Saturn already that have done quite a bit of science that's better than what this thing can do from the distances it was at. So this is more for New Horizons, checking the data, checking to make sure it works than anything else. Probe came closer to Pluto than Earth. That's pretty neat. And that, look at that, 2009. Half mission distance reached. Passing Uranus, closer to Pluto than any other spacecraft has ever been. That does not mean, however, that it was the farthest distance of all of our spacecraft. It just means it's the closest to Pluto. Voyager 1, Voyager 2, they are way, way out. Well beyond the place where Pluto would be in our orbit, but they never passed in the direction where Pluto is. And so they went out a different place of our solar system. So this is, at this point in 2011, the closest human-made object to Pluto.
Dave, I often wondered, they send these nice pictures back and all that, and how long does it take for whatever they use, the radio wave or whatever?
Yep. Well, it's all moving at the speed of light, and the speed of light, it takes approximately, just over 4 hours.
4 hours?
I'd have to check the exact time, but it's over 4 hours in light time. So that means if you're trying to tell the spacecraft to do something, so mission control is sending a signal, they send it out, it takes 4 hours plus to get there. The spacecraft does hopefully what you told it to do, and then you won't know if it did it for another 4+ hours. So you're talking an 8-hour day, and did something I did after breakfast work? You might know right after lunch, or towards dinner, right? So I would imagine somewhat frustrating, but there's no way around it. They're expecting it. By the time we got there, we're at 10 astronomical units. Just so you know, an astronomical unit, what is that? Does anyone know? AU? Yeah.
From the distance from the Earth to the Sun?
Good, yes. Distance from the Earth to the Sun, and so that's saying New Horizons is 10 times that distance at this point, 2012. So, New Horizons captures its first picture of Charon. Charon is Pluto's largest moon, and we're going to be talking quite a bit about this one in coming discussion. And it was done by the Long Range Reconnaissance Imager. That's the telescope. That's the one that does at this point in the mission at least, is doing the long range stuff. Later, it's actually going to, once we're in orbit, or not necessarily in orbit, once we're doing our flyby, this is the instrument that's going to get us our nice, very high detail surface pictures. So it's kind of twofold. It's distance stuff when we're out really far, and when we get closer, it's surface imagery. Now it's 5 AU. More pictures, and you can view these on the Pluto Safari app, which unfortunately this is not the app, but you could at your seats if you'd like. Passing Neptune. Awoke from hibernation. Okay, so we're on fully. The computers are up and going. We're trying to make sure everything's functioning properly. We're getting closer. We need to know. We need to fix something or have a workaround. Yeah.
Do you know that when they send New Horizons a signal, when it receives it, does it send back a little signal that says message received, so they know you've got it?
It's in constant communication. It's just a lag time of 4 hours. You know what I'm saying?
Yeah.
They're constantly sending and receiving signals, but you just realize that signal's 4 hours old.
And if you send a new something order on
I would imagine there's some sort of confirmation, yes. And you'll probably even get some sort of information as to how good of a signal it got. So, yes, the answer is yes. Observation of a Kuiper Belt object. This is a part of the solar system which you may or may not have heard of before. The Kuiper Belt is the location where Pluto exists. And we will be learning a lot about this through the study of Pluto. And we have learned a lot about the Kuiper Belt as a result. These are all, almost like asteroid type objects, and it's out beyond the orbit of Pluto. As I said, Pluto is part of it, so at and farther than the distance where Pluto is at. New Horizons begins to observe the Pluto system, moving into more observations, closer to Pluto than Earth is to the Sun. Now, this is kind of cool. So in early 2015, we finally got our first images that were better than what we had before. Because the Hubble Space Telescope has been taking images of Pluto from Earth orbit for years. And they are only a number of pixels. So we really have no clue at this point what Pluto looks like. We have some fuzzy images of a blob and another blob named Charon, and that's it. We can watch them go like around each other, and they're like, play old video games. It's like square things moving across your screen. You think they're people. This is the kind of thing that we were seeing. We saw two blobs flying around each other. We knew that they were a moon and Pluto. But beyond this point now, from this point forward, we're going to get better images. So we're moving in farther and farther. Flyby by Pluto and Charon was done on July 2014. Okay, and that's kind of where I'm going to pick up now. So I wanted to give you that sense of kind of how far we've come on our 9-year mission, and we're going to start talking about this in a different way. I'm going to use a few different websites, and I can post these if you'd like somewhere. Maybe we can make a subset of links or something on our website for you to get to these locations. And I can also post them in the video, below the video on YouTube, if you'd like to check these out. So the timeline here is where we were, but I would like to just kind of go to the news section. And this is where I spent 5 hours the other day. And I just wanted to show you this because I think it's probably your best resource. Each of these is a short article, maybe a 2 or 3 minute read, and there's tons of them. And they go all the way back to that very first thing. This is part of Sky Safari, which is an app for astronomy on your phone. And they made this, it's free, the Pluto Safari app, and it will continue to give you updates as new things happen. And in fact, they got, the New Horizons folks were pretty happy when this Pluto Safari app came out because they've done a good job with it, and they basically got the unofficial stamp of approval from New Horizons, that this is a good thing. So I decided this was my mode of research here, and I recommend to keep looking at it using this because it helps you out. I'm going to go to that date. So let's see, July 2015. And I'm just going to kind of click through some of these. We're, look at images. If you guys want to stop me at any time. But notice, look at this. We've got some information here before we actually get to Pluto. So let me just back this up a little bit. These are some of these are pretty cool. There's a video there. I'm not going to do the videos right now. First color movies of Pluto and Charon. Now this is pretty neat. You think, and there's the blobs. That's impressive? Yes. That at the time was like, whoa, look at this. This is the best images we've ever had. It's hard to believe, 2015. But this is the distances we're talking about. Now, anyone notice anything odd about this?
Well, the planet's moving. Like it's not stationary.
Okay.
Pluto.
See the X? The X is we put the X there, okay? The X is not actually there. It's not an X-wing fighter or something. Okay, this is the barycenter. This is the gravitational center between Pluto and Charon, its moon. And they are the biggest, they're the closest in mass moon and planet system in our solar system. In other words, Charon is very big compared to Pluto, and it pulls on Pluto quite a bit, to the point where Pluto moves when Charon goes around it. And their gravitational center is outside Pluto's surface, in space. And so, you know, imagine playing, like flying around with somebody else that's more massive than you. They're going to tug you around. Or if you have a little child and you're pulling them around, the bigger, more massive person is able to stay more in place, but you get tugged around a little bit. The more massive an object is pulling on it, the more the parent object is going to move. And they're literally called parent and daughter objects. So, any questions about this? We knew this, but we didn't have as interesting of a picture before. Yeah?
The Earth does that too, correct? So
Correct. Our moon, however, is not sufficiently massive enough to cause this kind of motion on the Earth. We do go for, you know, we are wobbling back and forth as the moon goes around the Earth. And our barycenter is inside the Earth, but not in the center. It's always somewhat towards the moon. And I believe it's somewhere in the mantle, the Earth's mantle, is where that location would be. Yeah?
Isn't that one of the reasons those things are actually orbiting each other?
They are orbiting each other. In fact, there are many scientists who feel that this should be a binary planet system, or dwarf planet in this case. Yeah, Harry.
If Earth were like that, would we feel it, or would we not notice that at all? Would it have an effect on tides differently than the way we are now?
I think it would definitely have an effect on tides.
Well, that's why we have 2 tides instead of 4 tides.
I'm not going to get into the tides discussion right now, but not necessarily. There's some other things going on there.
But you think we would know it? If we were living with, oh, okay, the Earth is moving around like...
My question would be this. Does this accelerate? Does it change its speed as it's doing this? If in fact it changed its speed, then it would be noticeable. But I have this hunch, I don't know for sure, I have a hunch that this is doing this at a constant rate. Anytime you have a constant rate of motion, just like driving down the highway, you could be going 65 miles an hour on 222 and not notice you're moving if you didn't have nothing on the road. So it's always when you accelerate, either hitting the brakes or hitting the gas, that you would notice that. So if it's not changing speed, you would not notice it. If it is changing speed, I guess, Rob? I would imagine you wouldn't feel it.
I tend to agree with you. However, I sort of think about if it's in orbit and it's doing this, you kind of would think if you traced out the orbit, you would kind of get sort of like a loop-to-loop sort of thing, which would make me think it is accelerating.
Yeah.
Then again, you're accelerating, you're moving with it.
I don't know.
I mean, we don't feel anything like that up
Keep in
there.
mind, changing direction is acceleration.
That's true.
Yeah.
Okay, and,
Good point.
and you combine that with the fact that gravity is so low there, you might feel it.
Interesting thought. Very interesting, Gary. Thank you.
So in other words, we have a lot of gravity here on Earth that holds us down, keeps us glued right here. Every time I get up out of the chair, I know that. If that wouldn't be the case, I don't think I'll turn on it. So maybe you would notice it. It's interesting idea.
Are they orbiting the same distance from each other?
No, well, they're from each other, well, yes. But from the barycenter, from this point, no.
It has to be an elliptical orbit, otherwise it wouldn't be stable.
Yeah. Yeah, it's ever changing, but yeah.
Now, this wasn't, was this considered when the International Astronomical Union renamed Pluto a?
Yeah.
Or this was part of it?
Oh, yeah.
Okay, that's what I thought. I didn't think that.
Yeah, I'm pretty sure this Pluto Charon thing has been known for decades.
Sharon was detected in the 70s.
When is that?
I think it was detected in the 70s.
In the 70s.
Sure.
Yeah.
The other moons weren't.
An interesting side note, the image was taken by that Lori long-range telescope, but the color was done by one called Ralph. Ralph stands for some other thing that it picks up the colors. So it's a spectrograph. And so they added those two images together to create this color image. So they've got color on one device and the long-range sensing ability on another. Kind of interesting.
I looked it up. It's just an 8-inch aperture telescope. It's a folded system, but it's not huge.
Okay. Yes?
If you combine the mass of Pluto and Charon, would it then be a full-sized planet instead of a dwarf?
No, it's still very, very tiny. Okay, so moving on to the next thing. I'm not going to go through all of these as I said, but I'm picking out a handful of fun ones. We're starting to see some surface features with these pictures, and once again, it's kind of one of these, you know, long distance ones. But notice with Pluto now, it's a little closer in, and they have a zoomed in picture down bottom here. You're noticing some variation in the colors, and that's key because we didn't have that information before. We only had those pixels. Now we're getting some actual, like it looks more spherical, and we're getting actual surface features. At this point, we're starting to get, there's Ralph. Hi, Ralph. At this point, we're starting to detect some things on Pluto. Methane gas, or methane in its vapor form. It's important to note that we had made this discovery through the Hubble Space Telescope prior to this image. The reason it's important is because now we know Ralph is working properly. We know we have what it takes when we get there to do good science. So this is a happy day for New Horizons people. This is kind of cool. We'll talk more about this. A red, so this is Lori, and this is Ralph, and this is Lori plus Ralph. Lori is the long-range one, Ralph is the spectrograph, and this is the combined image. And what they started to see was very interesting to scientists, a red surface. This red surface is an indicator of some sort of chemical composition. And the question is what is that? And we will talk about that, so if you know, I'm not going to give it away too much, but the discussion, you know, a lot of people are going to jump to conclusions here and think it's like Mars. That is not the case. Mars is red due to the rocks have iron in them, and when they react with oxygen, it creates iron oxide, rust. So that is not the case with Pluto. Pluto is made up of this very, very exotic type of environment where you have things like methane and nitrogen, which in our atmosphere, nitrogen is like 70-some% of our atmosphere. On Pluto, it is so cold that, I'm sure you're all familiar with liquid nitrogen. You've probably seen it on TV. Maybe if you've seen it in real life, the experiments, they can freeze things, and you hit them with a hammer, or you slam them on the ground, they shatter into pieces, right? Well, on Pluto, it's not even just liquid nitrogen, it turns into ice. It is that cold. And methane, ice. We're talking only a few tens of degrees above absolute zero. And as a result, it's very hard to describe the exotic, weird environment that you're going to be seeing on these upcoming images. One of the things that happens is that the sunlight will react, and I also believe it said starlight, will cause a reaction due to a very important line, which some of you may know of, not a big deal if you don't. It's called the Lyman alpha line. It's a part of the spectrum that is very much studied in astronomy. But basically what happens is that the sunlight reacts with this gas, and it creates what's called a tholin. If I'm not pronouncing this right, tell me. A tholin, T-H-O-L-I-N. And when this reaction occurs, you end up with this stuff. And this is like a laboratory experiment that they made these tholins. And you'll see on our upcoming images that Pluto looks a lot like that. And there's been some confirmation that that's the case. So there's that Lyman alpha light. It's part of the ultraviolet light spectrum, and it's an emission line on that. So, like I said, we're not going to get into too much detail with that. Questions on that tholins or red surface? Okay, we're going to go in even closer. We'll talk about that again. Everybody likes this one. How many people have seen this already? Here I thought I was going to have some news for you. My wife knew about this before I did. She's a biologist. I was like, oh, hey, cool, you know, this heart moon. He's like, I know. Whatever. Thought I could be nice and, you know, romantic. But interesting that this shape here is the light color, and in terms of scientifically. Light color, dark color, high contrast, interesting area. Unfortunately, we won't see that image when we get up close. That's on the opposite sun. So when we do our flyby and we get close to Pluto, we don't get to see it go around like in rotation. And so I think this is the last image, or one of the last images of this side of the fourth planet. And this would have been really neat to see. Hey, new mission, right? So, so kind of funny. And
it seems like they're saying that they did fly over that region. It's the opposite side. Perhaps.
Well, this is from a distance, though. I'm saying when we get our close flyby.
Yeah, they flew close flyby over that region.
Saying that there?
Yes.
Oh. Okay, maybe it was something else that I'm thinking of then. Okay. You're correct.
Maybe.
Yeah.
Is the heart is on the opposite side of Saturn?
Yes.
This side.
I don't know, so I'm gonna you know for sure.
Live like Sharon, it's on the opposite side of Sharon. To get a picture of Sharon, they had to go.
All right.
Like Pluto's here. Sharon's
So
here, they flew behind her to get a picture.
we also were able, with this mission, to refine some of our size information. How big is Pluto? How big is Charon? And we were able to determine that Pluto is in fact larger than we thought it was, which confirms what we thought, which is it is the largest of the dwarf planets. In the outer, I'm sorry, not the largest, it is larger than, I think it's Eris. Let's see. Like I said, I read 5 hours of this, so I'm sorry if I'm a little rusty. And they also put some of the moons of Pluto up here as well, so that you can get an idea with the sense if you've ever been to Denver. I really wish they would make this an app. I'm sure you could find one where you could put it on your own hometown, because that would be a little more easily understood. But they, I think, are based in Denver, if I remember correctly. So they use Denver as their model. Here's 10 miles for scale.
So is Pluto smaller than our moon, bigger than our moons? I mean,
I believe it's smaller.
than the moon?
Yes.
Wow.
And I think it's about 2/3 the size of our moon.
Yeah.
And,
So, you know, we're talking about an object that has, it's bigger than, you know, the minimum size it needs to be spherical, but it is close. You know, it's, you get down to a certain size and things start to be odd shaped. And if you look at Charon is also spherical, but you get much smaller than that. The other moons, they're not spherical. They're look like potatoes flying around in space. So,
Do you think that now that they know that it's a little bit bigger, it's classification?
it will not change. I will make that my own personal opinion. There's no way it should change. I'm a Pluto as a dwarf planet advocate. There's many reasons why, and I think we've gone over them in the last one. If you'd like me to talk about them again, I certainly will. But I don't want to. Does anybody want to know? You want to talk about it? Okay. All right. If you'd like to talk about it more, let me know, and I'll talk about it with you afterward. So, you know, we're really getting some really high detail now. And we can really start to do some science. And we're starting to look at things like craters. We're starting to look at areas that aren't very cratered. And this is an important thing. Because prior to this, we would expect these worlds to be cold and dead. But we're not finding that. We're finding that they seem to be fairly active. They seem to have resurfaced themselves, which indicates some sort of geology going on here. But you can't think of it like geology with Earth. Our geology is powered by what? Does anyone know? What's going on that causes our volcanic activity or earthquakes? What's going on? Radioactivity beneath the surface. And our rocks, the magma that's created, is what's going on. The magmas and the volcanics on a planet that's so cold like this, the rocks on planets like this, are likely water ice. The geology that's going on here is that ice in water ice is what's considered rock, and it's melting, and we've got things that are like this here, likely nitrogen, in its ice form, and it's flowing like glaciers, like water does on Earth. Wow. So we've got a completely different environment where methane and nitrogen act like the water cycle on Earth. However, that's the case in the inner solar, closer to this, like maybe Saturn, for instance, Titan. Titan has a methane atmosphere. It has the same process, liquid methane in pools on its surface. It goes through a water-like, the water cycle. It's the methane cycle of nitrogen. It's way too cold here for that. So what we have is we have basically two different states of matter. We can have nitrogen and methane in its solid form on the surface, or we can have it in its vapor form in the atmosphere. But there's no in-between. It's either gas or it's solid. The liquid phase is skipped completely. What's the process called? Does anyone know? What's the process called when we go from solid directly to gas?
Sublimation.
Sublimation. So we have sublimation occurring, and you may recognize this when you see dry ice. Dry ice, you have a nice hot summer day and you want to cool off, take some dry ice, put it in front of a fan, instant air conditioning outside, right? Or keep your ice cream from the creamery at Penn State cold. I know that's how I always get my dry ice. And I get ice cream too, which I really enjoy. So, we've got sublimation occurring. Does anyone know what is the opposite of sublimation? This one is the tough one. Everybody knows sublimation.
Freezing?
Freezing would be from liquid to solid.
Couldn't be that.
This skips the freezing stage. We go from gas to solid, which is deposition. So we have deposition occurring, we have sublimation occurring, we do not have melting and freezing. None of that occurs. No liquid. And so the question is, what does Pluto's atmosphere look like? And we're starting to get some indicators here that there's got to be something going on there. And we have had evidence of that for a while. We've known from basically like what Lane and Rob were talking about with the occultations of the moon, that when a star passes behind Pluto, like let's say a star way out here, if Pluto were to move over in front of it, instead of just blinking out like it would on the moon, we actually can see a dip in the light coming from it, indicating an atmosphere. And I'll show you if I can find it, an image that shows that. Before I do, we'll get to that one. This is something that scientists are, this is the one that I was thinking of that we're not going to get to see again. The Charon Mountain in a Moat. You see it? It's the zoomed in picture top left. We've got what appears to be like a crater or something going on there, and inside of it is a mountain. And planetary geologists have absolutely no clue, they say, how that can form. I have seen similar features, but nothing so pronounced. If you look at the moon, for instance, some of the very large impact craters have a mountain in the middle. We know the reason for that is when an impact hits, it liquefies the surface, and then as the crater is made, it's liquefied and it starts to rebound, like you drop water, drop a stone in water, and it makes that little drop that comes back out. Right? You know what I'm talking about? Drop it in, bubble, and it kind of like comes back out like this. Well, when it starts to rebound and comes back down, it solidifies and stays as a mountain in the middle of that crater. But that thing's huge. This is a different material. So who knows? Yeah.
Not to sound too skeptical, but how do they know that that is a mountain in a moat and not a shadow sort of trick or different soils, like how sometimes when
But Rob, that would not make headlines.
Fair.
NASA scientists baffled by mountain on a moat sounds way cooler.
True.
Cynic.
I don't know. You can see, I see this and I see a shadow, and we've got, the light coming in from this side, hitting this side of the mountain. This is kind of like the shadow, and you can do some, if you know the actual dimensions of your image, and you know the distance of your image, you can do some equations to determine the height of an object in the image. So I'd imagine that's what they're doing.
I do tend to trust the NASA scientists. It just reminded me of some of the moon landing hoaxers out there who say, there are 2 cameras, but it's just a weird soil arrangement that made the shadows look like they're cast in different directions.
Yeah, I don't know.
Right.
While we have Charon up here, this is not Pluto, it's Charon. We started to see the same things here as we saw back on Pluto. Way too low of crater count. It does not appear to be a static, unchanging world. It appears to be ever-changing, and the surface features appear to be about 100 million years old. Now that sounds really, really old, but it's not much compared to the 4.5 billion years of our solar system, which we are looking at these objects, hoping to find more out about our early solar system. So, in some sense, we're excited that Pluto and Charon are so wild and that they're so different than we thought. However, we're not necessarily getting as much of the information of the early solar system as we probably thought we were going to get. So, I'd have to do the math, but I think it's like somewhere in the ballpark of like 2% as old as the solar system, 100 million years. Help me out if that's, I think that's what I remember reading. So, Garrett, can you check? I heard a knock. I don't know. Somebody's locked out again.
Is the reason that these craters are not as big as they are because of the location compared to how large some of the craters are on the moon? Well, if that's
The
close
size is
to
an indicator of the impact object. And they are being reworked by geologic process on the surface. And we don't necessarily know what that process is yet. We'd have to do more investigation at that point. So I don't want to field that question, because I don't know. And we probably, I would say, at this point, I would say NASA would be saying that too much if they said an answer to that. As if we knew exactly why the surface features look the way they do. That's going to take a while. We might know by the end of the week, once we're done collecting the data. These are basically snapshots. Imagine walking, imagine taking a picture, a bunch of pictures, all on your phone, and then it gives you like the thumbnails. These are thumbnails. We're going to dig in deep into the data as the data pours in. These are thumbnails of what's to come. We will have, not for Sharon, I don't think, as much, but we're going to have a really high detail, and you'll see in a second here. Real high detail pictures. So I'm trying not to spend too much time early on here because I want to get to those. Yeah, Nix. Remember I said not necessarily round? This is kind of weird. Weird shape. And there's what we think it might look like. That's an artist rendition. Kind of a oblong thing. And there's a video if you'd like to see it then. And we can watch as the Pluto's candidate satellites and satellites move around them. So we're observing some of the other things that we've not had the ability to image before. I know that some of them were known because of their gravitational disturbance. I don't know if we've imaged them before. In other words, we can see Pluto wobbling as a result of other objects that weren't necessarily seen. We do stuff like this with our exoplanets as well, when we're trying to study if a star has planets or not. We watch for the wobble of that star, and if it wobbles, we'll know something's pulling on it. Icy frozen plains of the Tomball region. So this region is it Clyde Tomball? Am I remembering that correctly? The discoverer of Pluto. And in fact, that heart-shaped region that we looked at earlier, they've named it after him. Because Pluto hearts like Tomball. Because he discovered it. So it is unofficially named, informally named. I can't imagine this particular one is not going to stick. That would be pretty low on my totem pole of value. I think he should get it. He's discovering the place. And look at this. You've got really wild surface features that look like some sort of flow of something. Really, really weird. But they're not sure what's causing it. Might be some sort of liquefaction of some sort of water here, not water, but some sort of liquid form of methane or nitrogen. But it also could be like when something dries out, like a desert, where it starts to crack. So they're not sure if this is a very dry region that's causing these cracks, or if this is some sort of, the opposite I guess, some sort of liquid forming. And if I remember correctly, these are mountains. And those mountains would likely be water ice, as in H2O, the stuff we drink. And then there's a little flyover. This one's worth watching. So they have that flyover. This is, like I said again, thumbnail imaging compared to what we'll get. Whoa. It just kicked into the HD. It was actually, the video was in worse condition. It will be better than this.
We're getting into the heart now.
I believe that's the edge of the heart, and the mountains on the left were what we looked at earlier.
I think that was the edge of the data.
Well, this, yeah, that's the edge of the data way out there. Is that what you meant? Yeah, this right here is, of course, the edge of our data. This here is the heart, and these are those mountains we were looking at on the picture. And then when we get out here farther, go back there a second. This was the mountains we looked at originally on the edge of the heart, with that dark region. And then this is the lighter region. This is the edge of data again. And then this is more heart. Tomball, Ruggiero. Thoughts? Questions? Yes?
Can any living thing survive on Pluto?
Not to our knowledge at this point.
Ah,
It's way too cold.
right.
All right, so let's keep going. I have a handful of things to show you yet. Yes, Nix and Hydra. Hydra is, I want to ask you guys, I don't see it. Rubber ducky?
Yeah.
I guess this would be the bottom and this would be his beak or something?
No, on the left one, on the red area, looks like a rubber ducky.
Yeah.
That's how I see it.
I thought it was Hydra. I don't see the rubber ducky shape on either of them, so
I see it in Hydra.
if you can see it,
You see it?
Hydra's rubber ducky. Yeah, I don't see Hydra's rubber ducky shape.
It's like face down.
Yeah.
I
see it.
Yeah.
I see it.
I think it's Astro, it's even more like that.
Yeah. Here's a really neat shot. No, that's not. This is the occultation. This is how we know that it has an atmosphere, because otherwise it would drop straight off. But notice it kind of fades into it. That tells us there's an atmosphere there. If it were, then it would just go dink and drop, and then back up. But this part, instead of it being straight up and down, it's like this. This is light curve. So how much light we're counting? It curves slowly, indicating atmosphere.
Wait,
We can even find out composition of the atmosphere as a result.
That looks big.
It is big. It's enormous, in fact. From what I was looking at earlier, and I don't necessarily know that it's even in this. I read an article outside of this program. It's bigger than the Earth's. I don't know what that was.
Airplane.
Cosmic ray.
I think his wheels hit the roof.
Are we at war?
So the actual atmosphere is bigger than Earth's atmosphere, but it's much less dense. So let me just speed this up. We're kind of running out of time here. There's one more cool thing, a few more cool things I wanted to show you here. New Horizons sheds light on Pluto's hazy atmosphere. After we pass by, this is the picture we got of the sun behind Pluto. Isn't that cool? And this one is being thought of as, at least, this is the Pluto shot. I mean, this is pretty cool.
At the Black Bar Star Party, we had a PhD there from Johns Hopkins who's on the project, and he showed us a slide that showed there are at least 3 layers, perhaps 4 to the atmosphere. So, of course, they're trying to figure out what in the world is creating the layers.
This is one of those shots. You can kind of make it out there. You can see definitely a nice one here. And they go into detail later in here, these hazy layers. This is what he was showing you?
Yeah.
So you can actually see the layers here, Pluto's surface, 31 miles up, 52 miles up, different layers of the atmosphere of haze. They're trying to determine what those are made of at this point. And they have some ideas. So I'm not going to go into detail on those. I want to point out, this is a good one. If you want to recap what we talked about tonight, the top 10, what we've learned so far, I'd say this is a good read for everybody. Very short, and it recaps pretty much everything we've been talking about. This is not around Pluto. This is a comet that we looked at with the Rosetta lander earlier that I think Lane talked about. But we're just talking about this as being similar to Hydra there. We've got the same pictures we talked about earlier. I tried to go through these all with you today.
I flew behind Sharon too.
So if you read anything, if you don't want to read the whole thing, these are all worth looking at. But I think this was probably the best of the articles, and I, of course, read it last. There's updates that will continue to come pouring in as we have 16 total months of data coming back from New Horizons. There are other websites that I just simply don't have the time for tonight. There's the official New Horizons website, which is not a NASA website. It is a Johns Hopkins Applied Physics Lab is the mission control for this. So that's where you want to go for the New Horizons mission. But there is a NASA one as well, right here, in which they're talking about Pluto. And, you know, they certainly have lots of cool stuff as well. But any questions before we wrap up for the evening? Yes?
This is kind of off the wall. Could you put a picture, find a nice clear shot of one of those objects? Years ago.
Which object?
Pluto.
Okay.
Or Charon. Years ago, when I was preparing a lesson on some of this stuff for my students, I read that the noonday sunlight falling on Pluto was equal to an hour before sunrise on Earth. Now my question is, if we had a pair of human eyeballs on that New Horizons, what would they see compared to what we're getting? I have this strange feeling we're seeing some false images that have been intensified.
They actually
really
have
low levels of light out there.
I'm glad you brought that up because I had to like kind of cut stuff out of my discussion here, but right here it is. If you click on this link, for some reason it's not working right now. I tried it before we started tonight. But this Pluto time, and I believe there's also an app for this, but definitely on their website here. This supposedly will tell you, based on your location, you tell them where you live, what time to go out, and you'll experience the twilight at the right brightness as you would experience. So go there, go to the Johns Hopkins one, click on Pluto time, and you'll do exactly what you're saying.
But keep in mind, they're not trying to show you what your eyes will see. And that's why you've got a telescope on board, so you can see much better than your eyes.
Yeah.
Plus they use CCD detectors for the cameras, which are far better. That intensifies everything. Oh, yeah.
We would want that, yes.
And in fact, there's a whole ethics about what you do to the raw data that comes back, where what the project planners do, the people in charge, is they try to make it so that most of the pictures get pretty much the same treatment, so that it's not like, oh, we're trying to show this in one type of picture and this in another type of picture. They try not to erase data they don't want. You know, like even if it would make it look much better and more artistic and pretty, they won't delete it. I just listened to a podcast about it. It's interesting because you'll get those hoaxers who are trying to say, oh, there's an alien out there, and you erased it.
So if you're interested in these Tholins, there's a Planetary Society article on what in the world are Tholins. Might be worth your time if you're interested in finding out what this red stuff on Mars, or not, on Pluto is. Oh, one last thing. This is cool. I'm kind of a nerd, if you haven't noticed, which is a cool thing, in my opinion. There is this spot on top of Charon. Where is it at?
You have to pull up on high definition.
Yeah, I had it. Did I click out of that other website, I guess? Oh no, here it is. Here it is. So let me get to a picture of that. This one, I think, yeah, here, it has it on this one. This region, they've determined, is actually stealing the gases from Pluto's atmosphere by its gravity. and then they're falling onto the surface, being sublimated, or I'm sorry, deposited onto the surface, then being hit by that Lyman alpha radiation and causing them to turn into those tholins that we talked about, that red stuff. And the scientists, this is on the North Pole of Charon, and the scientists are kind of nerdy too, and so they've unofficially named it Mordor after the Lord of the Rings, terrible place that, that they have to travel to in the Lord of the Rings. So, I hope that sticks, because I would love to have a Mordor to talk about. Yes?
If you go to the upper right,
Yeah.
it's like a dark line and just over, yeah.
Yeah, I don't know. I apologize, I don't. I'm guessing it's one of these cracks or features like this that you're just seeing from the side. And there's some discussion as to what could form those as well. This is something we see on a lot of these small worlds, and once again, it indicates a lot of geologic action. Whether it's being torn apart or pushed together or whatever, it's going to have further investigation. I'm sure it will. So, I thank you all for coming out and watching tonight. Once again, I will post some of this stuff up on our YouTube channel if you ever get a chance to go there, and I'll post some of these links as well. All right? Thank you very much.